So now we come to a similar question that we just saw before in chapter 11, but this time we're not converting dosage rate to an IV flow rate. We're given the IV flow rate and we're going to convert it back to its dosage rates in milligrams per minute. So what we're going to do is we're first going to change our flow rate, which is given to us. The infusion rate, our infusion rate is going to be, it's infusing at 12 drops per minute. And we need to get that into, well, exactly what is 12 drops in milligrams and how long is that going to take? So those are essentially, that is where our logic, where our thought process is going. So there's one thing that we have at our disposal here. We know we have a drop factor of 10 drops per milliliter. We also know that we have a strength of our solution, which is 500 milligrams over 1,000 milliliters. So eventually we're going to want to use that strength, 500 milligrams over 1,000 milliliters, because the final dosage is asking for it in milligrams. And we also need minutes, which is part of that 12 drops per minute infusing time that we're given. So what we're first going to do is we're going to get rid of the drops, and the way that we can do that is by using that drop factor of 10 drops per milliliter. So if we take our 12 drops per minute and we multiply that by 1 milliliter over 10 drops, because again, the 1 milliliter is on the top because we want the milliliters to stick around. We need that for our next fraction. We're interested in getting rid of the drops. So the drops cancel out, which gives us 12 milliliters over 10 minutes. And then if we divide that, we get 1.2 milliliters per minute. So that is our first beginning of this question. So 1.2 milliliters per minute is equivalent to 12 drops per minute. So we still haven't answered the question. We've only converted drops to milliliters, and so we're still asking, well, exactly, well, how many milligrams is in 1.2 milliliters and over the same amount of time. So now we're going to use the strength unit fraction to cancel out the milliliters. We're no longer interested in that. We want the milligrams to stick around, and we also want the minutes to stick around as well. So we're going to take that 1.2 milliliters over the 1 minute, and we're going to multiply it by that unit fraction. And we want the milliliters on the bottom so that they cancel out. So we have the 500 milligrams. So those cancel out. 1.2 multiplied by 500 gives you 600 milligrams. And then 1 minute multiplied by 1,000 obviously would give you 1,000 minutes. But the question isn't wanting it in 1,000 minutes. It wants to know how much. It wants to know in milligrams per 1 minute. So we're going to divide that down. So 600 divided by 1,000 gives you 0.6 milligrams per minute, and that is answering part A, which is back to our dosage unit. Now, this question particularly is asking, it gives you the strength in milligrams and it asks for the dosage in milligrams as well. But don't be surprised if you're asked a question where it gives you the strength in milligrams and the final dosage needs to be in grams or the other way. So we still could be testing you in this test on your metric system, and that won't be given to you in your conversion chart. So please make sure you practice your metric system conversions, including milliliters to liters and vice versa. That could very well be an extra step that would count for an extra mark on a question like this. Now, for part B, it's asking us here, it gives us a range. The recommended dose range is between 0.5 to 2.5 milligrams per minute. Is our calculated, is the infusion of this in the safe dose range? Our answer we got was 0.6. So yes, this is in the safe dose range. We can totally do this. So to answer that question, it's just comparing our numbers. Yes, this is in the safe dose range.